In this video, we are still in discussion for numerical solution of first order ODEs. So, we are going to discuss how to solving system of ODEs, firstly using Euler method, and the second one by using fourth order Ranskata method. Many practical problems in science and engineering need to be modeled in the form of a system of ODEs rather than single ODE. So, in general, such a system can be represented as dy1 dx is equal to f1, dy2 dx is equal to f2, until dyn dx is equal to fn, which requires n initial conditions at the starting values of x. So, it depends how many equations of first order ODE that you have. In this section, we are consider our system of ODEs with n equal to 2 only. That means you just have two first order differential equations. So, in general, a system of two first order ODEs with y and z referred to as dependent variables and x referred to as independent variable has the form dy dx is equal to f1 xyz and also dz dx is equal to f2 xyz for the domain from x start from x0 until xn with the initial condition yx0 equal to y0 and zx0 equal to z0. That means the first initial condition is for the first equation and the second initial condition is for the second equation. Hence, the Euler method for system of ODEs. So, we have this. Firstly, xi plus 1 is equal to xi plus h. This is similar like the single equation. But for y and z, for yi plus 1, we have yi plus f1 xi yi zi h. And we add another equation. This is for z, where zi plus 1 is equal to zi plus f2 xi yi zi and h. That means you need to identify which equation become your f1 and which equation become your f2. Now, let's try to solve a problem. Example 1. Use Euler method to approximate the solution of this differential equation. So here we have two differential equations. The first one, dy dx is equal to minus 2y plus 4 exponent minus x, where the initial condition when x0, y is equal to 2. And the second equation, dz dx is equal to minus yz squared divided by 3, where the initial condition when x0, z equal to 4. For over the interval x start from 0 until 1, with a step size h is equal to 0.5. So the first step, I identify which one is my f1 and f2. So the equation number 1, I choose to be my f1, x, y, z. And equation number 2, I choose to be my f2, x, y, z. Then I construct a number line. So I start with x0 equal to 0. The step size is 0.5. Start from 0 until 1. That means x1 is equal to 0.5. x2 is equal to 1. When x is equal to 0, I have y0 is equal to 2 and z0 is equal to 4. From here, I need to find the value for y1 and z1, value for y2 and also z2. So here is the formula for Euler for system. We have xi plus 1 is equal to xi plus h. Since we have two equations y and z, so we have yi plus 1 is equal to yi plus f1 xi yi zi multiplied with h. And for equation z, I have zi plus 1 is equal to zi plus f2 xi yi, zi multiplied with h. So now I start my calculation. I start with I equal to 0. When I equal to 0, I have x1 is equal to x0 plus h. That means x1 is equal to our x0 is equal to 0. H is equal to 0.5. So I have x1 is equal to 0.5. Then for y, when I equal to 0, I will have y1 is equal to y0 plus f x0, y0, z0 multiplied with h. So I substitute y0 is equal to 2 plus f. x0 0, y0 is equal to 2, z0 is equal to 4, and h is equal to 0.5. So this is for f1. Okay, this is f1. So now we are going to substitute this value 0, 2, and 4 to our f1. So which one is our f1? So this is our f1. So you just substitute and then you just multiply with 0.5 and plus 2. So we will get our y1 is equal to. Now continue with z. So z1 is equal to z0 plus f2, x0, y0, z0 multiplied with h. So z0 is equal to 4 plus f2, x0 0, y0 2, z0 4 multiplied with 0.5. So now we substitute this value 0, 2, and 4 to our function f2. So where is our f2? So equation number 2 become our f2. So I substitute and then I multiply with 0.5 and then plus 4. So my z1 is equal to negative 1.3333. Now we already have the value for z1 and y1. Let's continue to find y2 and z2. So to find y2 and z2, I start with I equal to 1. So I repeat the process again. So I start with x2. So x2 by using this formula, so I will have x2 is equal to x1 plus h. So I will have 1. Then by using this formula to find the value for y2, so just same process as before. Y2 I will have 1.2131. And for the lastly, z2 is equal to minus 1.9259. Now, let's solve the first order differential equation by using fourth order Ranskata method. So we have two equations here. Dy dx is equal to f1 and dz dx is equal to f2. Since we have two equations, so this is our formula for RK4. Firstly, we have xi plus 1 equal to xi plus h. And we have yi plus 1 is equal to yi plus h over 6 multiplied with ky1 plus 2ky2 plus 2ky3 and plus ky4. The next one, we have zi plus 1 is equal to zi plus h over 6 multiplied with kz1 plus 2kz2 plus 2kz3 plus kz4. From here, we can see for y and z, we have ky1, kz1, ky2, kz2, ky3, kz3, ky4, kz4. That means you need to calculate this value for k. So this is the formula for k. We have ky1 and kz1. We have ky2, kz2, ky3, kz3, ky4, and kz4. Let's try to solve the example. Solve the system. Dy dx is equal to 1 over yz and dz dx is equal to y plus z. With the initial condition y0 is equal to 2, z0 is equal to 1 over the interval x start from 0 until 2 by using fourth order Ranskata method. and given to us the step size h is equal to 2. So firstly, I make my first equation as f1 xyz and the second equation as f2 xyz. Then I sketch my number line. So I start with x0 is equal to 0 and the step size is equal to 2. That means x1 is equal to 2. Given our initial condition, when x0, y0 is equal to 2 and z0 is equal to 1. So we are going to find the value for y1 and z1. Okay, by using RK4, we start with I equal to 0. So we will have x0 plus 1 is equal to x0 plus h. So x1 is equal to 0 plus 2. So x1 is equal to 2. Then we are going to calculate our y. So y1 is equal to y0 plus h over 6. ky1 plus 2ky2 plus 2ky3 plus ky4. While for z1 is equal to z0 plus h over 6, kz1 plus 2kz2 plus 2kz3 plus kz4. Before we can get the value for y1 and z1, let's calculate the value for ky1 until ky4 and kz1 until kz4. Okay, let's start with ky1. ky1 is equal to f1, x0, y0, and z0. So f1 is equal to x0 is equal to 0, y0 2, z0 1. So now we substitute this value into our f1. So this is our f1. So we just substitute. So we have ky1 is equal to 0.5. Then we continue with kz1. kz1 is equal to f2, x0, y0, and z0. So we have f2, 0 to 1. Now we substitute this value into our f2. So this is the equation for f2. So substitute, we have kz1 is equal to 3. Now we continue with ky2. ky2 is equal to f1, x0 plus half h, y0 plus half ky1h, and z0 plus half kz1h. So we just substitute all the value. So we have here 1, y0 plus half ky1h, I will have 2.5. And for this, for the last z0 plus half kz1h, I will have 4. So I just substitute into our f1. So I will have ky2 is equal to 0.1. Okay, how about kz2? kz2 is equal to f2, x0 plus half h, y0 plus half ky1h, and z0 plus half kz1h. So I will have f2, 1, 2.5, and 4. So I substitute into our f2. So I will have kz2 is equal to 6.5. Okay, next we calculate for ky3. ky3, so this is the formula f1, x0 plus half h, y0 plus half ky2h, z0 plus half kz2h. So I just substitute all the value. I will have f1 is equal to 1, 2.1, and 7.5. Then I substitute into my my f, so f1, so I will have ky3 is equal to 0.0635. So this is my kz3. F2, 2.1, 7.5. So my kz3, I will have 9.6. Next, I calculate for ky4. ky4 formula f1, x naught plus h, y naught plus ky4h, ky3h, and z naught plus kz3h. So I substitute the value, I will have 2, 2.127 and 20.2. I substitute into my F1, so my KY4 is equal to 0.0233. And lastly, I calculate for KZ4, so F2 to 2.127, 20.2. So I will have KZ4 is equal to 22.327. Then after we have all the value from ky1 until ky4, kz1 until kz4, so we can calculate the value for y1 and z1. So we start with y1. y1 is equal to y naught plus h over 6, ky1 plus 2, ky2 plus 2, ky3 plus ky4. So we substitute all the value that we have. Y naught is equal to 2. H over 6, 2 over 6. Ky1, 0.5. Plus 2 times ky2, 0.1. Plus 2 times ky3, 0.0635. Plus ky4 is equal to 0.0233. So I will have my y1 is equal to 2.2834. Then I continue with z. z1 is equal to z0 plus h over 6. kz1 plus 2, kz2 plus 2, kz3 plus kz4. I substitute all the value that we have. z0 1, h over 6, 2 over 6, kz1 3, plus 2 multiply 6.5, plus 2 multiply with 9.6, plus 22.327. So I will have my z1 is equal to 20.1757. So that's all about this topic. So I hope everybody can understand. So thank you guys.